Welcome to this explainer. Today, we are going to completely dismantle the water cycle. So go ahead and forget those static, honestly, kind of boring diagrams you might remember from grade school. We're going to reveal the dynamic, incredibly powerful engine that actually dictates your daily weather. It's this fascinating system of energy transfer, and by the end of this, I promise you, you'll never look at a rainstorm the exact same way again. Here's a quick roadmap of how we'll break this down. First, the solar power engine. Second, upward, evaporation and transpiration. Third, transformation into clouds and pressure. Fourth, the gravity return through precipitation. And finally, we'll wrap up with the weather connection. All right, let's jump straight into part one, the solar power engine, turning the ignition. Every powerful machine needs a spark to get going, right? Well, ours is absolutely no different. In your mind's eye, picture solar radiation beaming down directly from the sun. The sun is essentially acting as our ultimate energy source. That intense solar radiation heats up the liquid surface water on Earth, and that absorbed thermal energy is so incredibly powerful, it literally breaks the molecular bonds holding the liquid water together. Once those bonds snap, the water goes through a massive phase transition. It transforms from a liquid into a vapor gas. And because it's now a gas, it naturally just begins to rise right up into the atmosphere. Now here's where it gets really interesting. How do we actually label that energy? We call it latent heat. Latent heat is simply the thermal energy distributed throughout the atmosphere during a phase transition. You see, this entire hydrologic process is fundamentally about distributing energy. It's taking the sun's immense thermal energy, packing it directly into the water itself, and then allowing that water to act as a sort of invisible carrier, transporting all that energy high up into our skies. Moving on to section 2, upward. Evaporation and transpiration. Basically, two paths to the sky. Okay, so the engine's running and we've got our energy source. But how exactly does all this water get up into the air? Well, water actually takes two primary upward pathways. The first is one you definitely know, evaporation. That's just liquid surface water directly absorbing thermal energy from the sun to become a gas. But there's a second, honestly often overlooked pathway, and that's transpiration. This is just a brilliant biological process where plants literally release excess water vapor into the air through these microscopic leaf pores called stomata. It's essentially the Earth's flora breathing, and it contributes a massive volume of moisture to the sky above us. And this brings us to our very first direct weather connection. You know that sticky, muggy feeling on a humid day? That rising water vapor traveling upward from oceans and plant leaves is directly experienced by us down here as humidity. That upward movement of vapor we just traced is precisely what creates that heavy atmospheric moisture. So it's not just sticky air. You are literally feeling the water cycle mid-phase transition. Now, because this humid air is absolutely packed with vapor, it's actually lighter than the dry air around it. I know, it sounds counterintuitive, but it's true. And because it's light, it continues to rise. As it pushes upward, it explicitly forms those low-pressure weather cells that meteorologists are always tracking. When you hear them talk about a low-pressure system on the news, just picture a massive, rising column of humid, super energetic air. Let's hit section 3, transformation, clouds and pressure cooling down. Let's follow that rising vapor high up into the upper atmosphere. The environment up there changes drastically and really fast. Watch this rapid sequence unfold. That rising water vapor hits the colder upper atmosphere and cools rapidly. Because it's cooling down, it just can't hold on to that energy anymore. So that stored thermal energy, the latent heat we packed away earlier, is finally released into the surrounding air. This loss of heat causes the vapor to condense right back into liquid water droplets. But to actually form a visible cloud, those droplets need to group together. Here's the catch, though. They don't just group onto empty space. Actually, scratch that. They literally can't. They require something called condensation nuclei. These are just tiny airborne particles. Think microscopic bits of dust, smoke, ash, or even sea salt. The liquid water droplets group onto these particles to form visible clouds. Without these tiny airborne anchors floating around up there, those liquid droplets wouldn't be able to clump together effectively to give us the cloud cover we see every single day. It's like a giant puzzle coming together in the sky. Which brings us to section 4, the gravity return. Precipitation, the crash back to Earth. What goes up must come down, right? The upward journey driven by the sun is really only half of this engine's cycle. As these cloud droplets cling to their condensation nuclei, they continuously aggregate. They just keep bumping into each other, combining and combining. Eventually, these grouped droplets gain enough mass that they become heavy. And once they become too heavy for the atmospheric updrafts to support them, physics simply takes over. Gravity forcefully pulls that whole mass right back down to the surface. So gravity crashes all this moisture back down to the surface, and it comes in a few different forms, completing the whole loop. Depending on the exact atmospheric temperatures it encounters on the way down, it hits the ground as rain, snow, sleet, or hail. And boom, the matter has fully circulated. Finally, Section 5, the weather connection engine outputs. Okay, so we've seen all the mechanics, but how does this actually impact the forecast you check every morning? Well, our source material nails it with this quote. The local availability of atmospheric moisture and the release of latent heat during condensation are the direct drivers of localized weather events. Put simply, it is the precise combination of that atmospheric moisture we traced from the ground, plus the explosive release of latent heat high up in the clouds that actively manufactures your local weather. So when those humid, low-pressure cells we were talking about earlier finally crash into cooler, denser air masses, the engine essentially outputs its real visceral power. That collision, which is completely fueled by the release of all that stored solar energy, results in really aggressive atmospheric outputs. We're talking heavy cloud production, intense wind tracking, and severe storms. That clash, that is the engine running at maximum RPM. So I'm going to leave you with this to ponder. The next time you feel a storm brewing, the wind picks up, the pressure drops right before a downpour, ask yourself, whose latent heat are you feeling? That storm's energy was captured from the sun days ago, stored in a lake or maybe a forest canopy miles and miles away, carried invisibly up into the sky, and is now violently releasing its heat right over your head. It's an incredible, fully connected engine. Thanks so much for joining me on this explainer, and keep looking up.